Hey guys, it's Periodic Pals here. My goal is to break down chemistry concepts to make it simpler for everyone to understand. Today we'll be talking about the mole concept and stoichiometry, specifically on relative masses. So to start off, we'll talk about the carbon 12 scale. Okay, this is important because when we're talking about the masses of atoms, right, they're very small, in the range of 10 to the power of negative 24 to 10 to the power of negative 22 grams, right? So instead of talking about the masses in terms of grams, scientists actually use a relative atomic mass scale to compare the masses of different atoms. So chemists agreed on using the carbon 12 atom as a reference standard for relative atomic masses. The isotope of carbon 12 atom was assigned a relative atomic mass of 12, and the relative masses of all the other atoms are obtained by comparing their mass with the carbon 12 atom. Okay, we will describe more about this on the subsequent few slides. So to start off, we discuss on the relative isotopic mass. Okay, this is just a definition that you should know about. It's very commonly tested on how we define relative isotopic mass, how we define relative atomic mass, and so on. Okay, so it's important to understand what this definition means. Okay, so how it's defined is essentially the mass of atom of the isotope that we're talking about, right, divided by 1/12 of the mass of one atom of C12. Remember, we mentioned that one atom of C12, right, is assigned a relative atomic mass of 12. So 1/12 times that 12 just essentially gives you 1, right? Okay, so for example, we have this neon 21 isotope. This 21 here refers to the nucleon number or the mass number, which we talked about in the previous video. You can check that out, right? So 21 here refers to the total number of protons and neutrons. And remember, we mentioned earlier that electrons are actually relatively insignificant in terms of their weight. So the mass of this neon atom is contributed mainly from the nucleons, such as the protons and neutrons. Okay, so we can see that the relative isotopic mass is very close to 21. Okay, it's 21. The relative isotopic mass of chlorine is close to 35. Okay, so we can see that in terms of the relative isotopic mass, they are often very close to a whole number. Reason being because the relative masses of the proton and neutron are both very close to 1, and electron having a negligible mass. Therefore, it follows that all relative isotopic mass will also have close to whole numbers, because they're essentially just an addition of the protons and neutrons, right? You have 21 protons and neutrons in one neon atom here. You have 35 protons and neutrons in this chlorine 35 atom. Okay, therefore, we mentioned this statement, relative isotopic mass is roughly equals to the nucleon number, which is the sum of the proton and neutron. Okay, this is just a simple illustration of how we obtain the relative isotopic mass. Remember, we mentioned earlier that the mass of one atom is very small. So for in this case, the mass of one chlorine 35 atom is 5.81 times 10 to the power of negative 23 grams, so a very, very small amount, right? The mass of one carbon 12 atom is 1.99 times 10 to the power of negative 23 grams, also a very small amount. So you can see that comparing this chlorine atom to this carbon atom, the ratio is essentially 5.81 to 1.99. We can disregard this 10 power negative 23 here because they are the same, right? So the ratio is 5.81 to 1.99. If we divide both sides by 1.99, we get 2.92 is to 1. And remember, we mentioned that this carbon 12 atom is assigned a relative isotopic mass of 12. So we times both sides by 12, right? We get 35 for chlorine and 12 for carbon. So essentially, this is what we mean when we say relative mass, because we're always comparing to this carbon 12 atom here. Okay. Important to note that when we're talking about relative isotopic mass or relative atomic mass, etc., there should be no units because it is relative, right? It's all relative. There are no units when talking about this kind of numbers. Okay, moving on. Earlier we talked about the relative isotopic mass. Now we'll talk about the atomic mass, which is seen by this symbol here, A subscript R. Right? So the definition is very similar to earlier. The only difference now is that now this is a weighted average. So why is there an average in this case, right? It's an average in this case because we know that relative atomic masses actually take into consideration the different isotopes and their abundance in nature. Therefore, it is an average because we're actually taking into account all the different isotopes. Okay, so for instance, the relative atomic mass of chlorine would be 35.5, which is not a whole number because in this case, this is a weighted average. Okay. So this is an example showing how we calculate the relative atomic mass of chlorine. Okay, so as mentioned in our previous video, which you can check it out again, we have two different isotopes, chlorine 35 and chlorine 37. Chlorine 35 is more abundant, which 75.53% compared to 24.47% of chlorine 37. Okay, so essentially, if we want to find the relative atomic mass, which is the weighted average, right? For instance, in a sample of 100 chlorine atoms, you have 75.53 of them being chlorine 35. You would have 24.47 of them being chlorine 37. So in a sample of 100 chlorine atoms, we can take 75.53, right, times the relative isotopic mass of 34.97 over here, okay, plus 24.47 of the atoms times 36.95 over here. What we get at the numerator is essentially the total relative mass, right? If we take into account the different abundance, this is the total relative isotopic mass. But remember, when we talk about AR, we want to find the weighted average. So we take the total mass divided by 100, which we talked about earlier, right? 100 chlorine atoms. So the total mass divided by 100 will give you the average of 35.5. You can see that this number lies closer to 35 compared to 37 because we have a greater number of chlorine 35 in nature. Therefore, the weighted average is a closer number to 35 than 37. Okay, this is just the periodic table of elements showing you the different elements as well as the relative atomic mass that can be seen at the bottom here, right? So for instance, carbon, this 6 is the proton number, 12.011 is the relative atomic mass. Chlorine, which we talked about earlier, proton number of 7, 35.453 is the relative atomic mass when we actually took into consideration the different abundance of the isotopes. Okay, moving on, we'll be talking about the relative molecular mass as well as the relative formular mass, both having the same symbol, M subscript R. Okay, the difference why we have two different names is that molecular mass is more relevant when we're talking about molecules. Molecules apply for molecule elements such as chlorine gas, Cl2, or oxygen, O2. These are molecule elements, right? Molecule can also come in the form of covalent compounds such as carbon dioxide, CO2, and water, H2O. Then we have formular mass when we talk about ions and ionic compounds. Ions such as hydroxide here, OH minus, sulfate, SO42 minus. We have sodium chloride here as ionic compound, sodium bicarbonate here as ionic compound. Yeah, so molecular mass applies more for molecules. Formular mass applies more for ions and ionic compounds. But the symbol is the same and the concept is also the same. So in terms of definition, it is very similar to what we mentioned earlier, right? Remember, we're always comparing to the reference standard, which is 1 atom of carbon 12, right? That's the reference standard. And the definition is the same. Okay, so relative molecular mass or formular mass is very simple. Essentially, how we obtain this number is that we take the sum, right? The total of the relative atomic masses of the constituent atoms. So for instance, we can see for oxygen molecule, O2, right? We have 2 oxygen atoms in 1 O2 molecule, right? It's O2. 2 oxygen atoms in 1 O2 molecule. So the MR of O2 would be 2 times the AR of oxygen, right? Which is 2 times 16. Therefore, give you MR of 32. We're talking about the formula mass of sodium chloride. So the MR of sodium chloride would be the sum of the AR of sodium and the sum and the AR of chlorine, which is 23 from sodium and 35.5 from chlorine, giving an MR of 58.5. Okay, it's very simple. Okay, so we're coming to the end of the lecture. So we can discuss this question before we end it off. You can give the video a pause and we'll go through the question in a bit. Okay, so the question is, what is the relative molecular mass of glucose, which is C6H12O6, right? So this is glucose, is a covalent molecule, right? And this is just for reference, right? We know that the relative atomic mass of carbon is 12, hydrogen is 1, and oxygen is 16. So remember, when we find the MR of this, it's essentially just a sum of the AR of these constituent atoms, right? So the answer would be 6 times 12, which is the AR of carbon, plus 12 times 1, which is the AR of hydrogen, plus 6 times 16, which is the AR of oxygen. Adding all together, you should get a MR of a total of 180.0, right? So that's the answer. Alright, so we'll come to the end of this video. Please like and subscribe if you think that this video has been helpful for you and you'd like to see more of such videos in the future, right? So study hard and see you guys in the next video.